to say, okay, how do I, thank you, how do I, how do I get those nutrient deficiencies up in my soil so that they're not deficient? As I said before, different labs, different results. There is no uniform soil analysis report. Different labs will use different um, processes in the lab to test your soils. Most of them use strong acids. There are a couple labs around the country that use weaker acids. Some will even do tests with water, not typical tap water. It's deionized water. So yeah, Cornell is going to be different. Here in New York, Cornell lab, um, you can do their cash test, or you can do a la carte and get a what would be a more normal uh, soil test. Dairy One is one of the examples we'll look at. We have a dairy farm, so we use Dairy One. Penn State would be different. Private labs are different. Um, and then I have a note here for small veg and gardeners might want to investigate Logan Labs. They have a few different tests that are a little more useful for folks who have gardens or market gardens. Like I said, the Cornell cash test, it's the comprehensive assessment of soil health. They measure more than just your mineral content and your organic and your pH. I can go into a little bit more of that later on, but it also tests, it gives you more of an essay, I should say, of soil health for aggregate stability, predicted soil protein, soil respiration. And then they also break down organic matter and active carbon. Those are two very different components of soil organic matter. All right, so what do we get on a test? So we get pH, which is a test for acidity. Our soils can be either acidic or basic, depending on, again, where it falls on the pH scale. You'll get a percentage of organic matter, cation exchange capacity. Sometimes it'll be written as CEC, all capital letters. And then it can give you nutrient levels of your fields, your beds, your garden, things like that. It's not, again, not exact. It's more of a range of low, optimal, or medium, and abundant or over excess. And but they give you a foundation to work from. It is important to know what we have in our soils, what is there, and then again, like I said, there are some other tests to let you know what is actually available to the plant during the growing season. And then again, another thing is to say, okay, well, I've got my soil test. What am I seeing in the field or in my garden? Do I have pests? Do I have weeds? And we can get into other resources that folks can look into if you want to for more of that observational part of how you link your soil test to what's going on in your fields or your gardens. Um, excuse me. So soil pH, if you've taken a biology or a chemistry course, more chemistry than biology, but you've probably studied pH if you even in the high school level. It stands for the potential of hydrogen. Some people say the power of hydrogen, and it measures the acidity or alkalinity of the soil. So water is what it's based on. And so there's a hydrogen atom and then there's a OH, which escapes me for the second as to what that is called. But if you have more hydrogen available in solution, your water or solution will be acidic. The funky thing about pH is it's a logarithmic scale. So when you go from a pH of, let's just use, our example here at the bottom of 4, and you get your pH up to 5, so it's getting less acidic and more basic, it is 10 times, the hydrogen ion activity is 10 times less. So I had that written backwards. I apologize. It's going from 5 to 4. The hydrogen ion activity is greater at 4 than it is at 5. I apologize. And pH level affects every plant nutrient and mineral because some nutrients are not available at ultra high or low pH values. They get kind of bound up in the soil. Microbial activity will not be enough to release those nutrients. CEC, as I said before, is cation exchange capacity. It stands for, I shouldn't say stands for, it's the easiest way to think about CEC is looking at it like a battery, whether that's a car battery. Most folks have seen that. There's so much in the soil that can be held, and your CEC kind of tells you that. We use CEC later on to help figure out base saturation. But if you have a high CEC soil, so clay soils, clay loams, soils with really high organic matter are going to have a higher CEC. They're going to have more capacity to hang on to ions, anions, in the soil itself, on bonding sites, and also hopefully in solution that's available to our plants. Some soils do struggle to retain nutrients, and those are usually lower CEC soils, like sandy soils, soils that can be overworked and you don't have much organic matter. They tend to leach, and the nitrogen cycle can be a little tricky in those soils. And again, the low CEC soils we can increase their CEC by adding organic matter, which then turns into soil organic matter over time, but they'll never have as high a CEC cation exchange capacity as a clay soil. Clay soils are just very small particles that have a huge amount of bonding sites. So if we think of a clay soil particle as something like a sheet of paper, there's bonding sites all the way around it. Where if you have a cube, there may be only 4 or 5 or 6 bonding sites on a particle of soil, sandy soil. It's not as electrically strong in holding bonds either. So before I jump to nutrients, I just wanted to say that, we have to remember that plants are, depending on what plant you're talking about, 95 to 97% carbon, hydrogen, and oxygen. And thankfully, we get a lot of those things free from the air and from rain. So that's the thing we have to think about. So plants are mostly carbon, hydrogen, and oxygen, but that 3 to 5% that they need from the soil, we have to make sure they're there and available. So nitrogen, a lot of times on a soil test, there will not be an actual measure for nitrogen. Everywhere is different, but you'll see when I pull up a couple of them of soil tests later, you'll see neither one of them have anything as to what is the level of nitrogen. Now the Haney test, which I mentioned at the bottom here, does offer that. So if you're, a broadacre field crop guy, you might want to have, or woman, you might want to have a Haney soil test done. The thing that's really nice about nitrogen is it does like to bond. And so if you have high levels of soil organic matter, it'll hold on to them. And as the season goes, microbes will release those bonds between nitrogen and organic matter, and hopefully we'll have enough for our crop that we're growing. If we don't, we can add, especially at the garden garden/market garden size. We can side dress, we can foliar feed, fertigate, things like that. Broad acres, it's a lot harder to do. Next is phosphorus. It is a vital plant macronutrient, as it says in the slide here. Plants cannot create energy through photosynthesis, which relates back to ATP. There has to be phosphorus available for the plant in order to have ATP happen, which is producing energy.
Chris,
yeah.
before you go too far,
Sure.
is nitrogen different than nitrate on a report?
So nitrate is a form of nitrogen. We can get into that a little bit later if folks want to. There's nitrate and nitrite. Those are two plant available forms of nitrogen. One is better than the other. But yeah, we can talk about that a little bit later. I hope I answered the question at least enough. So plants cannot make new roots, shoots, leaves, flowers, or fruit if there isn't sufficient phosphorus available during the growing season or at critical times of the growing season. Potassium is another nutrient that you're going to see on soil tests. So these first three are considered, NPK is like the main focus of conventional ag. It's important in organic ag too, but on organic farms, we're hopefully looking at more than NPK. And I know that there's a movement now for folks that are in conventional ag, regenerative ag, to look at more than that. But all along, organic farmers have had to look at more than NPK. So potassium, again, another vital micronutrient for plants. Plants that lack potassium grow weak, floppy stems and low quality fruit, if they even have fruit, because potassium, you have to have potassium in order to fill the fruit, whether that's a grain of wheat or a tomato or an apple. Um, there can be a little confusion between not enough potassium and not enough nitrogen because your leaves will yellow. The difference is where on the leaf is that happening. And for anybody who's a gardener and you get into a dry spell later in the season in August and you haven't watered in a while, you'll notice your tomato leaves will start to curl. That is because potassium isn't available to the plant because there isn't water for potassium to be in solution. And the only way plants can take it up is in solution. Well, it's not the only way, but it's the biggest way. The other way is through foliar feeding. But again, without enough water, it won't cycle through in the plant. All right, so calcium is one of my favorite minerals. It's extremely important in our soils. It can be a problem and usually is a problem in garden soils and on a lot of ag soils, especially in the Northeast here, where we get a large amount of precipitation. Water and heavy snow will push calcium because calcium it's a heavy element. I believe it's actually, if I look at I believe calcium is considered a metal on our periodic table. But again, it's a heavy element that goes down through the soil layer. And we want it to be, if possible, in the top 2 inches, especially available. And there's a correlation between low pH and a calcium deficiency. If folks want to talk about that later, I can get into that a little bit more too. Magnesium is essential. Plants have to have it in order to form chlorophyll. It makes the green pigment in a leaf. They fluctuate closely with soil calcium and potassium. On a lot of clay soils, if the magnesium is out of balance with calcium, soils get really tight and sticky. They can crust over very easily and they're tight, so water will not infiltrate. And as it is, a lot of clay soils don't want to let go of water. And that's because usually there's too much magnesium and not enough calcium. So each of those clay particles are held really tight together. And it does affect the growth of plants. We need air circulating into our soils and gases that are coming off from decomposition, from fungal and microbial activity. We need to be able to get that CO2 out of the soil. So we need them to be airy and open. There's a few things that can happen when there is a magnesium deficiency. Again, the biggest one is, is there enough available for the plant to make chlorophyll? But it's involved in a lot of other things too. It's involved with fruit fill. It's involved with building stems. There's a lot of things that happen with all the nutrients actually. Sulfur, and so this is a micronutrient, and it's crucial to protein synthesis and photosynthesis. Without it, plants cannot produce chlorophyll and they struggle to metabolize nitrogen for proper growth. And we are now seeing a lot of researchers are saying, hey, since we are no longer burning as many carbon sources, so like coal and low sulfur diesel fuel in our trucks, in our home heating oil, we used to get that for free. And I say free because there's nothing free in life, but it used to come down precipitation onto our soils. And in the Northeast for years, we didn't have to apply sulfur. But now a lot of researchers and farmers and consultants are starting to say, hey, you know what? We need soil or sulfur in our soil in order for things to happen. And actually it says at the end here, so we have nitrogen fixers, legumes, so like beans, peas, alfalfa, clovers, things like that, without sulfur in our soils at a sufficient amount. The little bacteria, rhizobacter, that colonize the cells of those plants on their roots, they can't do their job. They can't fix nitrogen out of the soil. And as it says here at the end of the slide here, it also needs molybdenum, which is a trace mineral. Very small amounts are needed per acre, but without those two things, it's hard for legumes to sequester and fix nitrogen. Copper is another trace mineral. Again, we don't need a huge amount of copper in our soils, but it has to be there for enzymatic activity, chlorophyll and seed production. And it's also, we're starting to realize, and a lot of researchers are now realizing that all of the trace minerals are extremely important in enzymatic function. And without them, our plants are they're not gonna function correctly. Manganese, again, another trace mineral that doesn't have to be large volumes, but we have to have them in our soils. It is needed for regular plant growth and functioning. And also, if there isn't enough manganese in the soil when seeds are being formed, those future seeds will not germinate. I think it was Charles Walters from Acres USA who called it the spark of life. Without manganese, and this is actually just a sidetrack, quick one. Without enough manganese in the human body, folks will not be able to have children. So we're not much different than plants. So we need small amounts also, just like plants. Zinc is another micronutrient. It's essential for plant formation of chlorophyll and hormones. So you can see that there's a lot of interplay between trace minerals. So like zinc, copper, manganese, moly. There's a bunch of them. I think there's 64 to 74 nutrients that a plant needs in order to really function. They work together with manganese or with magnesium to make chlorophyll. And then they work with other minerals and to make plant hormones. And now a lot of researchers have come out in the past few years and said, hey, you know what? Copper and zinc, we're starting to see that, they aid in cold tolerance for plants. Not that something like sweet basil is going to survive a 28-degree night, but if you get to 32 and basil has enough zinc and copper, it might survive. Maybe the top leaves will get burnt and die, but maybe the plant will survive. And if we get a nice little warm spell, they'll come back. It also helps fruit trees in the spring to, if we have a late frost and blossoms are on, it will help. I'm not saying it's going to save every flower and every fruit, but it does help. And the last one is boron. Again, boron is heavy, not really available in most soils in the Northeast. And around the world, actually, it is the most widespread plant deficiency. And it is critical for calcium and boron to work together to build plant structure and to build healthy plants. And just so that's the end of my slideshow. Here's contact information for us folks here at NOFA New York. I apologize, I didn't put mine on here. My email, mine is chris@nofany.org. You can always send information or questions to info@nofanewyork.org. We have a farmer helpline. You can see the number there. We also have on Tuesday afternoons a farmer forum. It's not just for farmers, it's for also processors and folks like that to come with questions about certification, issues you're having, and farmers too, and gardeners and everybody, really. Anybody who has a question about agriculture, come and ask. We're here and we're always looking for more questions. We're always looking for more feedback. And then of course our website is NOFA New York at org. And then, all right, I'm gonna open up the questions. I'm going to stop sharing my screen as soon as I can get rid of that. All right, there we go. I will stop sharing. And did my screen go off, Sam?
It did.
Okay,
Uh,
awesome.
so just one more couple comments in here from Hannah.
Sure.
She said, so the pH 8.2 on my soil analysis equals sad soil at the moment.
Well, yes and
Um,
no. Yes and no. So the question becomes, Hannah, why is it 8.2? So is it that there's excess magnesium? Because I should have put this in the slideshow. Magnesium is 1.4 times as strong as calcium to make our pH go up. So okay, I'll go into this. Here we go. Okay, so do you have a soil test in front of you? Okay,
Yeah,
awesome. Okay, so does it have base saturation in there?
it does not, but I do have those tables for magnesium and calcium.
Okay,
can I just interrupt for 1 sec? Would it be
sure.
helpful to have like
Yes.
your soil test up on the screen, Chris?
Yes, pull one of those up, please.
Okay, I'm going to share my screen with that. Okay. Does everybody see it?
All right. So this is a soil analysis from I think a couple of years ago from one of our pastures. And so this is our barn field. So the barn field is right behind the barn. Over the years, it's got humongous amounts of manure and bedding and things like that. So if you look down a little bit further, you'll see where it says on the right-hand side, base saturation value percentage. And so K is potassium, calcium, magnesium, Na is sodium, and then H is hydrogen. So we would like to see calcium in the 70 to 75% range of base saturation. That will make our soils air and loose, have plenty of calcium in the soil for plant available nutrients. Microbes need calcium, and they're the ones who actually free it up. And then, so like I'm a little low from where I actually need to be, even though if you go back up to the section above, it says calcium is very high. If you look at base saturation and that value, those two numbers don't really match up with each other. So I will be applying lime to most of our farm. Um, and that's one of the fields. And once we get extra calcium up, and if we can get that to be a higher percentage, magnesium's percentage will fall, and we want that in the 12 to 14 range. Sodium and potassium, they have their ranges too that we want them to be in. I don't pay attention to them quite as much because we're in the Northeast, so we don't really have to worry about sodium quite as much. The water grabs on the sodium and flushes it down through the soil profile. But we would like to see, here we go, here's my notes here. We would like to see potassium in the 3 to 5% range. And sodium, we want 0.5% to 3% max. And so that's why I asked you, if you had those values in front of you to say that your pH is 8.2. And this is going to sound crazy, but is it a garden, a market garden?
So it's a field.
Okay.
So I've got 5 different tests from 1 acre plots. And my soil test doesn't have a base saturation value, but I can see what you're talking about with like it measured in parts per million. And that field, it was classified as like a sandy loam, and most of the soil is in the back.
Okay. So again, sandy loams are a little difficult too. So with the sandy loam, you're actually going to want a little bit more magnesium because it's going to hold those particles together and hopefully have them and organic matter hold on to more of your nutrients. Now, sandy soils are awesome for growing vegetables and things like that. But you have to be careful with what is being applied and you might have some issues with other trace minerals because
Mhm.
they can leach down through the soil profile so quickly. If you want to shoot me an email or if you want to join the farmer forum sometime, we can go definitely a lot more in depth. And I can. So where are you located?
Yeah, that would be great. I know I was going to say regional differences make a big impact on what you're going to be applying for amendments. So I'm in Tucson in the Southwest in Arizona.
Ah, that's why your soils are higher also. I should have asked that first.
Hmm.
Um, so out west, you don't get as much rain. My uncle lives outside of Phoenix, Arizona. Um, and because you don't get the rain, a lot of the ions hold on in the soils, and you probably have lower organic matter.
Yeah.
Yeah. So if you can increase your organic matter in your soil and turn that into, so like when I say organic matter, if you can add mulches, compost, litter, leaves, all kinds of stuff. I mean, you're going to want to watch how much you put on of that because you need nitrogen to help break it down. But that will also change your pH. And all that organic matter will hold on to soil nutrients. So it's a little bit trickier out west, but things can still be done.
Yeah, thanks for that. I was wondering if you could maybe speak a little bit more to on your test where you said, I can't remember what element you were mentioning was low, but you would be adding lime. And I was just interested if you could kind of touch on what are some of those amendments that you recommend for different deficiencies.
Sure. Sure. So for calcium, we're gonna want to go with high calcium lime. And if you are low on, say, something like sulfur, also, you could use gypsum. That's calcium sulfate. Um, Eggshells are fantastic for calcium because they're bioavailable already. The chicken's done all the work. So the microbes in the plants can break that down and get that into their system really quick. Are there other things that you were curious about besides just calcium or?
Well, I was wondering, yeah, what's another source of natural source of sulfur and like could you spread wood ash? So you mentioned something about burning, and I was curious because in one of our fields we had a lot of old growth mesquites that we had burned and then planted a cover crop. And in some of those areas where we had the burn pile, I noticed a significant amount of a better growth from the cover crop that was planted.
Right. So burning is good and bad at the same time. So any minerals that were in the wood itself are now going to be ash particles, which are going to be available. And like I said before in the slides there, those mesquite trees are probably 95 to 97% just carbon, hydrogen, and oxygen, right? So you have increased the carbon content. Have you ever heard of biochar?
Yeah, but I don't know much about it.
Okay, so biochar is very similar to burning wood, say like in a wood stove, but it's at a very low oxygen content in the burn, so it's called pyrolysis. And what you end up having is very structured pieces of burnt wood or whatever material you decide to burn. Mesquite is actually a pretty good one to do it with. And I mean, people buy mesquite for barbecues and things like
Mhm.
that. Um, So, but before you would add something like that, you have to charge the biochar. So compost teas, other soil amendments that you can add to your compost pile and have that compost pile start to break things down and make them bioavailable. It's a great home for mycorrhizal fungi. Um, yeah, there's a lot of things that you can do. But
Thanks.
sure, no problem. And like I said, if you have other questions, you can always shoot us an email or join our farmer forum on a Tuesday at 3 o'clock. So, were there other questions here, Sam?
Uh, no, not yet.
Okay. Okay.
Um, so do you want any more of those soil tests shared? Did you
Yeah.
want to
Can
just
you
open it up for discussion?
sure? Can you put that one actually the other soil test that you had from Dairy One that I sent you today? Can you put that up so we can take a look at that to
Is
look at
that
some of the
this one?
trace? Nope, the other one. Leave this one up. We'll talk about this. So this is part of the comprehensive assessment of soil health from Cornell University. They call it the CASH test. And what they do is they've collected hundreds, probably even thousands of soil samples from across New York State and in other places too, Pennsylvania, Vermont, New Hampshire, all over, send soil samples. And then they take off the information of who sent it in and then put this all into a huge database and compare soil types and regions and say, okay, what do you have going on? And also they broke it down another layer to what's your production model? So is it crops? Is it an orchard, a vineyard? Is it pasture on a dairy farm? Is it dairy production, but like more like on a confinement type deal where it's corn silage on corn silage on corn silage, maybe back to a grass or alfalfa, back to corn silage. They broke them down a little bit. So this sample that's in front of us right here, I was part of a soil health group, and this sample actually came from one of the higher production conventional confinement dairy operations milking 300 cows, but this sample came out of the hedgerow. So this is not completely accurate as for what is going on in those soils on that farm, but this is the hedgerow. And then what they did was they took a sample in the corn silage, and then they took a sample in the hedgerow so that we could compare them. And I do have the other one here somewhere. But as you can see here, they describe what is the soil type. It's 40% sand, 44% silt, and 16% clay. So this is a sandy silt loam. And then, so they have the indicator, which is either the name or the test that they did. And then they assign it a value compared to everyone else in the data set. And then they give it a rank. So dark green is the best, and lighter green is slightly down. And then I believe it goes orange, and then red is the lowest of those. So you can see here, like their soil pH is 7.4. They have it as 100, but that's actually too high. 7.4, there's certain elements that will get locked up. Their extractable phosphorus is 6.9, which there again they have as a ranking or a rating of 100. I don't keep everything in my head. I try to, but certain things. So when I see extractable phosphorus at 6.9, and I believe they report everything as parts per million. So in my mind, that phosphorus is actually low. But I know that a lot of folks are saying, there's a lot of phosphorus bound up in soils, and that we don't want them to leach into our waterways and our streams and rivers and things like that. For me, that's still a low number. So, and then if we go down like further and we look at the bottom there and we look at all those additional nutrients that they have on there, and we look at sulfur at 14.8, and I got into a slight argument with some folks about trace minerals at this meeting. We actually want sulfur to be a lot higher than 14.8 parts per million. In all of the papers I've been able to read from Europe, the United States, cutting edge type of things where folks are saying, no, we need quite a bit of sulfur. They're saying 75 parts per million is the minimum. I'm not saying we want to go a whole lot higher than that. And again, it depends on your context, your soil type, how strong of, how big of a battery, the CEC that we talked about before. But that's low. And so like all of the trace minerals, the boron, the copper, the manganese, zinc. Well, manganese is actually pretty close, but everything else is pretty low. So yeah, sure. Go ahead, Anna. You got a question?
Yeah. So when you mentioned like the phosphorus being low, what would you do to amend that? And how do you determine like the rate of application?
Okay. So phosphorus sources are a little bit funky. The biggest one that organic folks use is bone char. So that is actually bone. They call it bone char, but it's actually not burnt. It's smashed up bones from beef cows usually. There's another product called bone char that is burnt beet pulp. So you have to be careful where you get that from because it could be a genetically engineered beet pulp. You can buy it organic too. So those are the two main ones for organic folks. If folks are on the conventional chemical train, they're going to buy acidified salt fertilizers, which are higher potency, higher analysis. But I mean, we're organic, so I try not to talk about that stuff too much. Those are a lot more water soluble, so they will leach faster than some of these organic sources. Sorry, I gotta look in my notebook here for other sources of phosphorus that are considered organic. There's some in leaves, green parts. You know, there's also what I'm sorry, I'm at a loss for a second here. Come on, where's it at? Fish emulsion and sea kelp is another good spot. And you're also going to get the trace minerals from the kelp itself. And there's growth hormones in kelp that's going to help with root growth and things like that. Yeah. Like I said, I can sure.
Oh, that's super helpful. Would that be, would you apply that then prior to planting your cover crop or in cooperation, like at the same time?
When do you plant your cover crops?
Well, we have a longer growing season. And so I planted one this past October, and I'm looking to plant a more heat tolerant Sudan grass for a shorter amount of time in the next couple of weeks.
Okay. So, and what are you going to do after the cover crop? Are you going to plant some kind of veg crop or?
Yeah, that's the goal, is to start with this cover crop, tarp, mow it, tarp it, and then rotate it back in with a BCS tractor, and then prepare the beds for vegetable production.
Okay. So, fall is a great time, especially with something like bone char, some people call it bone dust also. It's a great time to apply it because it'll break down the whole fall and winter. What is available will go into the plants. So even in this, when you're planting the sorghum Sudan grass in a few weeks, even applying it before then is a fantastic way to do it because the microbes will be active in the soil because of the roots that are in the soil growing from the cover crop. So it is a great time to put it on, amend it with whatever you need before you put on your cover crop seed and start growing. So yeah, that's a great way to do it.
Got it. Thank you.
Sure. Yeah, Sam, you can take that test down unless somebody has a question about it. And then I see what we got here over in the chat. Yeah, there is a biochar company in the Finger Lakes. That's right. That's awesome. Thank you for mentioning that, Christy. And Emily, sure, I can discuss soil temperature affecting nutrients. Absolutely. So things like phosphorus, for instance, are completely, in order for them to be freed up during the growing season, temperatures have to be above a certain point in order for biology to be active to start digesting phosphorus for us. For instance, I see you have here potassium. A lot of nutrients in the Northeast here, when it's a cooler spring, like right now, right? We got March 21st here. Grass is starting to green a little bit. There's not a huge amount of microbial activity. There's always some, even in the dead of winter. There is some activity under the snow, under the frozen soil. It slows way down, but it's always active. But a lot of nutrients are not available when the soils are cold. So as the temperatures rise, they do become more available because the bacteria and the fungi become more active in the soil to start breaking those things down. And then once you get into the growing season and the temperatures are really warm and the plants are growing beautifully, the plants are putting a whole bunch of, exudates into the soil to feed the biology that's in the soil. So the microbes and the mycorrhizal fungi, as long as they're there, they become active and the cycles really start working. And that's another thing that's really cool. So anybody who wants to, and especially if you till your soils, inoculate all of your seeds in your garden, in your market garden, whatever it might be, even on broad crops. Think about inoculating with a mycorrhizal fungi. They're not a broad range of mycorrhizal fungi species. It's usually 3 or 4, whatever that lab might be growing. And I'm not saying that everyone is going to work in every circumstance, but it's better than having nothing. And if you put it right on the seed or your seed potato, or if you don't put it in the seed or on the seed when you're starting in the greenhouse, make a soil drench and put it in that, or take some kind of flattish kind of container and dunk your seed trays into that soil solution so that those spores can attach to the soils and to the roots. We have to have mycorrhizal and microbial activity in the soil in order for our plants to be able to get nutrients. And a lot of folks are starting, even on the chemical side, there's a ton of companies out there around the world trying to sell biostimulants, and they're selling it as biology, packing it as biology, and something is better than nothing. Of course, we want to foster what is in our area as much as possible. But just something to think about, inoculating our seeds, and things like that. Oh, excuse me. Does anybody else have any questions? We've got plenty of time. No takers? Okay. So when I first sent this out as for a description of what the webinar was going to be, I also included how important plant roots and the soil microbiome are. So I'll go into that a little bit since we've got plenty of time and nobody's popped a question up or anything. As I was saying before, without soil microbiome, we do not have available soil nutrients to the plants. And we have to ask, how do we get that soil microbiome? It's everywhere. It's just a question of, is it active or not? So forests have them, grasslands, prairies, they're active everywhere. And we need them in agriculture. So we need to build a symbiotic relationship between plants and the soil microbiome because they work hand in hand. So as I said before, with healthy plants, once they hit a certain level, they're going to put sugars back into the roots. And I forget the woman's name. I think she's from Australia, Christina Nichols, maybe. She calls it liquid carbon because basically sugar is carbon. It's C6H12O6. She calls it liquid carbon. And if we have that liquid carbon train going, plants are putting a huge amount into the soil, feeding the microbes. And it's the crazy thing, plants can actually change the chemistry of what they are putting into the soil through those exudates to encourage either a stronger bacterial microflora or a higher fungal microflora. And with most crops, we need a balance of bacteria and other soil-borne microbes like protozoa and pseudoscorpions and things like that, and fungal activity. The fungal activity is what makes a lot of phosphorus available. And they have huge networks. They can go out and scavenge for water, phosphorus, other micronutrients, and bring them back to the plant in exchange for sugar. And we as farmers, gardeners, growers, we need to really push that forward and get that really cycling. And with that liquid gold, that carbon train that we're forming, that's how we're going to sequester huge amounts of carbon in our soils. And we want to put carbon back into the soil to hold on to nutrients, pull it out of the atmosphere, continue to grow better crops, build that soil microbiome, and it's just going to keep building on top of itself. And sometimes it takes longer than we like it to, but we can build topsoil that way. And it's something that as growers, farmers, we need to be thinking about that, encouraging it, doing our best to make that happen. So just something else to think about. And like I said, living roots around the calendar is the best if possible. So Hannah, awesome that you're growing multiple cover crops in 1 year. That's fantastic, especially in a place that is hot and dry like Arizona. But again, take advantage of those high carbonaceous plants like a sorghum or a Sudan. They're going to make huge volumes. And another thing you might want to think about in the future, you don't do it right now, of course, is a cover crop cocktail. Right? So you're going to have your grass species, your brassica species, and especially if folks have compaction, you're going to want to grow a tillage radish, which is a daikon radish that has been bred to grow deeper than a typical garden daikon. A grass species for that really fine root part, really fine root matter that they make and put into the soil. And then the last thing is another species. It could be sunflowers, it could be buckwheat, and those 4 or more. I mean, Gabe Brown is out there planting 26 different species or more. And each one of those different species is going to bring something to the table. They're going to add a different root structure. They're going to add a different bacterial species that are going to come with them. Again, some are going to break up hard pan if we have them in the layers. And then again, all of them are going to put roots into the soil, and all of them are going to have plant exudates that are going to be awesome for the future crop and for the soil microbiome. Like I said, it's amazing how different everything can be once you start growing cover crops. And sometimes it takes a while. If the soil is kind of, slow and sluggish and not a lot of activity, cover crops definitely bump that up. And it's awesome to be able to fit that into whatever rotation you have, whether, you're a corn and soybean grower, figure out a place to put it. If you're a home gardener, try and figure out a place to do it. You're talking about, either cutting them or trampling them and then tarping them to get them to senesce and stop growing underneath that tarp. Fantastic. It's awesome.
Thank you.
And
Could I ask one more question?
absolutely.
Okay. So one of the recommendations in my soil analysis report, and one of the elements you talked about that I'm interested in also figuring out how to amend that, is the magnesium. And one of the recommendations from this test, it says to get started, apply 40 pounds of magnesium per acre. The magnesium application will help balance the salts and increase the water holding capacity. And that's kind of another two-part question, is what, when in the Southwest, our water is very high in salines and alkaline, I believe. So how does one balance like with what's also in the water, is kind of one of those things you had mentioned.
Right. So are you using city water to water your vegetables and
No,
stuff? Okay.
it's on a well.
Okay. It's on a well. Okay. So magnesium is a little tricky. They're saying 40 pounds to the acre. Okay. One of the easiest places to get it, honestly, is magnesium sulfate, which is Epsom salt. I mean, you can buy it at Walmart, Price Chopper, or I don't know what grocery stores are out there, but health food stores, health like CVS and Walgreens and things like that, places like that for magnesium. Trying to think of some other sources that won't hopefully change your pH a whole lot. And another thing too is, so this is actually something that is a little out there, but in order to help correct the pH also, you might want to apply sugar. So it's a carbon source and it's going to fuel the soil microbiome. You can, again, add it as just straight sugar, or you can make a slurry. So any kind of green material is going to have magnesium in it. Somewhere around here, I have a list of really good sources of magnesium. Um, but yeah, Epsom salt is usually a big one, especially if you need sulfur. I will say, so let me find this again here too. So there's certain levels of minerals that we should put on, and we should only go to a certain point. Like we shouldn't just be like, okay, well, call it for, you know, 400 pounds of something. You don't want to put that all on at once in a year. Give me 2 seconds. I will be right back. I have to find this list. I'm going to turn off my camera for 1 second. Where in the hell?
So I just put a link to our resources page, which shows there's a link for the farmer forum there, and our farmer helpline is available to not just farms that we certify, but anyone with questions about how to farm using more organic practices. So please feel free to reach out, or spread those freely to whomever are in your networks. Did anyone else have questions that I might be able to help with?
Sorry about that. I couldn't find it, but I have a picture on my phone, so I can read this out for you. All right. So you can do, as I said before, magnesium sulfate. And with that, you're going to want to put on a max of, where is it here? Why is it not showing me this right? Okay, that's not what I'm looking for. Dang it. So a Solpomag is another thing you can use. That's sulfur, phosphorus, and magnesium Solpomag. So that's SOL dash MAG dash. Am I spelling that right? Solpo. I'm sorry. SUL dash PO dash MAG. Solpomag. Sorry. And that is a mined rock type material. Solpomag. That's really much better to apply in the fall. It's going to give you sulfur, magnesium, and potassium. Why do I not have that? Huh. Interesting. Sorry. There's other sources too. Sorry. Yeah, Hannah, if you send me an email, I can send you a whole list of all kinds of different, soil additives that we can use.
Great, I will. I'll follow up.
Sure, sure. Sam, did anybody else have any other questions? Sorry. Okay.
Nope.
All right. And you said something about the farmer helpline I just heard before.
Yep.
Okay. Yeah, so that's my spiel, that's my shtick. I mean, I can talk about soils and how we can be better gardeners and farmers. And so seriously, ask your question. If you don't have a question about soils, ask them a different question. We're here, we've got time. Are you having an issue in your garden with a certain pest or a certain weed? They're all, as I mentioned before, they're all indicators to us as to what could be possibly missing. And the soil test is, so if you put your soil test, and you have that in front of you, and you're out in your garden or in your field, and you're like, wow, geez, what's this weed? So, if anybody wants to know about that, we can talk about that a little bit too. But sorry, Sam, what'd you say, babe?
I think if that's it, I'm going to end the recording.
Okay, cool.
And yeah, thank you all for coming. I hope it was informative.
Yeah, absolutely. And if anybody has any follow-up questions, like I said, shoot us an email, join us on the farmer forum.